have already discussed about the shallow zone, how the shallow zone of P wave and S wave fall due to the earthquake. So today our topic is some basic terms, some basic physical terms, mainly physics. From this, the questions are asked in the exams, like in the exams NET, GATE, and JAM exam. Numericals are mainly asked from this portion also. So we have to focus on the numericals and by a slight idea about the theoretical concept. Okay. So first of all, I have written here what is elastic modulus. You may know if you have read physics in your previous class that elastic modulus is the ratio between the stress and strain. Okay, the ratio between stress and strain. Due to stress, the strain is generated. What is stress? Force per unit area. And what is the strain? The change in the shape of the object due to the applied stress is the strain. Okay. Now, what is Young's modulus? This is our second term. Young's modulus is the ratio between the longitudinal stress and longitudinal strain. So we basically denote Young's modulus in Y. Okay, will be equal to force upon area, force per unit area, and longitudinal stress, change in length, LL is the change in length, and L is with the original length. I have illustrated this in the previous lectures also. Suppose this is a rod, and due to the force is applied here, the area of cross section is A. So it will be stretch. So if this is the original length there, the change in length will be there, and the strain will be change in length and divided by original length. So stress will be okay. So here F is the force acting on the body, A is the cross section area of body, then L is the change in length along the longitudinal axis, and L is the original length. Now let's move on to the bulk modulus. Now what is the bulk modulus? So bulk modulus is denoted by K, and this is equal to the ratio between volume stress upon volume strain. So volume stress is called the hydrostatic pressure acting on body. This is the hydrostatic pressure acting on body, and V is the change in volume, and V is the original volume of the body. Here I have written V is the hydrostatic pressure acting on body, then V is the change in volume of body, and V is the original volume of body. Okay. Now the next terminology is shear modulus. Okay, so shear modulus will be equal to shear stress upon shear strain. So it is basically denoted by mu, and shear stress will be denoted as tau, and shear strain will be denoted as tan of psi. Okay, so mu will be equal to tau divided by tan of psi. Suppose this is a block, and we apply shear stress at the top of the body of the block, and it will shear in this direction. So originally the body was like this. But due to this applied shear stress, it is the body. This portion moved to here. Okay. So it will come like this, and it makes an angle. This angle. Okay. So this angle is called angular shear, which is called psi. Now, the next terminology is Poisson's ratio, which is denoted by sigma. Okay, so sigma will be equal to transverse contractional strain divided by longitudinal extensional strain. So, to explain this, I am giving you an example here. So, imagine we are stretching a cylindrical wire. Okay, along its length. So along its length, we are stretching a cylindrical wire. So when we stretch a solid body, so cylindrical wire is a solid body. Along the direction of we stretch a solid body along the direction of longest dimension of a body. It will extend in that direction. Suppose this is a cylindrical wire. We are extending this in this direction. So it will stretch like this and simultaneously when it is stretching, the length will decrease. The breadth will contract. Contraction here, the contraction takes place. Here the extension takes place. So this contraction divided by this extension, we call this sigma. So that is I have written here. So when we stretch a solid body along the direction of the longest dimension of a body, it will extend in that direction. It will extend in this direction. This is called longitudinal extension. This is the longitudinal extension. And it will contract simultaneously in the direction perpendicular to the longitudinal section. So this is the perpendicular section, and it will contract in this direction. It is extending in this direction, it is contracting in this direction. So the ratio between this contraction and this extension we call the cohesion ratio sigma. Okay. For very hard rigid rock like granite, sigma is approximately equal to 0.45. For soft poorly consolidated sediment, sigma will be equal to 0.05, and the interior of Earth, sigma, the value of sigma ranges from approximately 0.24 to 0.27. A body for which sigma value is 0.25, we call this ideal cohesion body. Remember this, sigma is equal to 0.25, and this is called ideal cohesion body. So in the interior of Earth, the material is nearly equal to the ideal cohesion body value. So in this section, we are going to discuss the relation between velocities of body waves and elastic modulus. So first, cohesion solid. Okay, so it is an isotropic elastic material for which Lamb's elastic constant lambda and mu are equal. It has sigma is equal to 0.25. So it is an ideal cohesion body. Okay. So the velocity of propagation of body wave in any homogeneous isotropic material is given by relation V will be equal to appropriate elastic modulus of material divided by density of material, which is rho. So here this is the derivation of velocity of P wave. So velocity of P wave will be equal to 4/3 mu plus k divided by rho, and for velocity of S wave will be equal to mu divided by rho root over. This is 4/3 mu plus k divided by rho root over. Hello everyone. So here I have written some relations between k, e, mu, lambda, y, sigma, velocity of P wave and velocity of S wave. So first here k, what is the k? K is the bulk modulus, will be equal to 2/3 mu plus lambda. Okay, so mu is the shear or rigidity modulus, and lambda is the Lamb's constant, and e is the mu 3 lambda plus 2 mu bracket divided by lambda plus mu, and k is equal to y, Young's modulus, divided by 3, 1 minus 2 sigma, and mu will be equal to y divided by 2 into 1 plus sigma bracket, and sigma will be equal to lambda divided by 2 into sigma plus lambda plus mu, and sigma will be equal to half of bracket velocity of P wave divided by velocity of S wave square minus 2 whole divided by velocity of P wave divided by velocity of S wave whole square minus 1. So here Vp is the velocity of P wave, Vs is the velocity of S wave, mu is the shear or rigidity modulus, and k is the bulk modulus of elasticity, rho is the density of material through which the seismic wave are moving, and lambda is the Lamb's constant, y is the Young's modulus, and sigma is the cohesion ratio. So from these equations, the questions are asked in the exam like NET, GATE and JAM exam. So we are going to solve some of the numerical. Okay. So here this is the first question for you. I have this is the GATE 2017 question. So if you know the answer, and can solve. You can try it by yourself, then comment me and check the answer. I am solving this. So the question is, the travel time difference between the arrival time of shear wave and P wave observed at a seismogram recorded at the epicentral distance of 100 km from a near source earthquake is dash second. So he is asking about the travel time difference between S wave and P wave. So what data he has given? This is the distance he has given, and he is asking us the time, and the velocity is given. So you know the formula: velocity is equal to distance over time, or displacement over time. So the velocity for velocity of P wave. So he is asking about time, right? So time into velocity will be equal to distance, and time will be equal to distance by velocity. Okay. Now he is asking about the difference. So the difference is velocity of time required for S wave minus time required for P wave. This is the difference. Say S wave minus P wave, time required in reaching. So Ts will be equal to distance by velocity. Distance is a constant, that is 100 km, divided by velocity for S wave is 3.5 km per second, minus the distance 100 divided by velocity is 6 for P wave. Okay. So by solving this, this is 28.57 minus 16.66, and here is your answer, 11.91 second. So the answer will be 11.91 second. Okay, done. So here this is the another question for you, numerical. The S wave velocity in the lower continental crust is 6800 meter per second, and density is 3380 kg per meter cube. Find the relativity in gigapascal. Okay, so here the data he has given is the velocity of S wave is 6800 meter per second, and the density rho is 3380 kg per meter cube, and he is asking about the rigidity. Okay, so you know the formula: velocity of S wave equal to mu by rho root over. So he is asking about the mu. So here velocity of S wave is, so by squaring both sides, Vs square will be equal to mu by rho. Now Vs 6800 multiply 6800 will be equal to mu by rho 3380. So mu will be equal to how much? 6800 multiply 3380. Okay, so now look, the unit, the game is for unit. So gigapascal. So gigapascal we have to divide 10 to the power 9 for gigapascal. Okay. When he was if he was asked about the pascal, then this will be our answer. But since he is asking in unit gigapascal, so 10 to the power 9 will be divided. So the answer will be 156 156 divided by 10 to the power 9, and the answer will be 156 point. Okay, in GeoPhysics. 156. So there is no point here. 1562912 divided by 10 to the power 9. So 10 to the power 4. We got 156.2. You can calculate by yourself by using calculator. The calculator is also given in the desktop in the exam. So the answer will be 156.2 gigapascal. Okay. So here another question is from GATE 2014. So the question is, if at a particular depth velocity of P wave is 11.5 km per second and velocity of S wave is 6.5 km per second and density is 5.0 into 10 to the power 3 kg per meter cube, the bulk modulus of rock is S. So the data velocity of P wave is 11.5 km per second and velocity of S wave is 6.5 km per second and density is the rho is 5.0 into 10 to the power 3 kg per meter cube. So what will be the B? So the formula for bulk modulus is K is equal to 4 by 3 mu plus K divided by mu plus K divided by rho root over. This is the formula. You have to remember the formula. Okay. So by solving this, K is equal to 4 by 3 and velocity of S wave. The formula velocity of S wave is equal to mu divided by rho. Velocity of S wave square is equal to mu divided by rho. So So here velocity of S wave square is equal to mu divided by rho. So we are calculating for mu. So this is the mu. So we are putting the value of mu in this equation. The value of mu 4 by 3 bs square 6.5 plus k divided by 5 into 10 to the power 3. So by solving this equation for k, the velocity of P wave is also given 11.5 km per second. So I am using this. So in this question, two formula are used. This will be equal to velocity of P wave is velocity of P square. Okay, 132.25 is equal to 4 by 3 into 42.5 plus k divided by 5 into 10 to the power 3. Now you can easily solve for k. So our final answer will be k will be equal to 226,750 divided by 3. Okay, by solving this 226,750 divided by 3, the value of k will be found. So here this is another question. If the velocity of P wave in a given material is twice the velocity of S wave, then its Poisson's ratio will approximately be dash. So here velocity of P wave is twice the velocity of S wave. So velocity of P wave divided by velocity of S wave will be equal to 2. So you know the formula of Poisson's ratio. Velocity of P wave Vp by Bs square minus 2 divided by Vp by Vs square minus 1 root over. Okay, this is the formula for sigma for Poisson's ratio. So sigma will be equal to half of this velocity of p wave square by half of velocity of p wave by velocity of s wave whole square minus 2 the whole divided by vp by bs whole square minus 1. So put the value half of vp by bs to 2 square minus 2 divided by 2 square minus 1. So half of the numerator will be 4 minus 2, that is 2, and denominator will be 4 minus 1, that is equal to 3. So the answer is 2 by 6. So this will be equal to 2 1 is 2, 2 3 is 6, 1 by 3 will be equal to 0.333. So the answer will be 0.333. Okay, this is unit test, stress open strain. So this is all about the numerical portion of the equation based on different relations. So this is the end of the lecture. Thank you for your patience. In the next lecture we are going to discuss sinusoidal wave equation. What is the wave equation, energy amplitude relation, and attenuation of seismic wave velocities of rock. And after that we will shift to the main detailed idea about the earthquake, how earthquake happens, its magnitude, its intensity and magnitude scale. So thank you. If you have not subscribed our channel, subscribe, and if you have not joined our Telegram channel, join our Telegram channel. So now thank you for your patience.